Hi, Assalamualaikum. My name is Siti Saleha binti Muhammad Ali, S70208, and today I will explain the boiler blowdown process in a marine smoke tube boiler and its importance in preventing scale and corrosion. What is a smoke tube boiler? A smoke tube boiler, also known as a fire tube boiler, is a type of marine boiler where hot combustion gases pass through tubes and water surrounds the outside of these tubes to absorb heat and generate steam. During operation, impurities and dissolved solids in the water gradually accumulate at the bottom of the boiler, which can affect performance and safety. This is where blowdown becomes essential. What is boiler blowdown? Boiler blowdown is a controlled process of removing water from a boiler to eliminate impurities like sediment, sludge and concentrated dissolved solid, also known as TDS total dissolved solids. These impurities come from minerals such as calcium and magnesium or from chemical reaction during steam generation. If they are not removed, they can lead to scale build-up and corrosion. Now, before we see how blowdown is done, let's quickly talk about the types of blowdown. There are two main types. The first is intermittent blowdown. This is done manually at certain intervals, usually once a day. It helps remove sludge and sediment that settle at the bottom of the boiler. The second type is continuous blowdown. This happens automatically in a small, steady flow and helps control the amount of dissolved solid in the water. In most marine smoke tube boilers, intermittent blowdown is preferred because it safely removes settled impurities and keeps the boiler in good condition. Next, I will explain the boiler blowdown process in a marine smoke tube boiler. We will start with the bottom blowdown process. The boiler contains water with sludge composed of suspended particles, which tends to settle at the bottoms of the boiler drum over time. The accumulation of sludge increases due to continuous steam generation. The bottom blowdown valve, located at the lowest point of the boiler drum, is open. This allows the sludge at the bottom to be discharged by the internal boiler pressure. The high velocity flow of water creates a securing effect, removing sludge and sediment deposited at the bottom and near the heating surface. This prevents sludge from hardening into scale and improves heat transfer. During blowdown, the water level drops temporarily and boiler pressure decreases slightly. These changes are controlled by keeping the blowdown duration short, usually about 15 to 30 seconds. After sufficient sludge has been removed, the bottom blowdown valve is closed to prevent excessive loss of water and heat energy. Fresh with water enters the boiler to replenish the lost water, helping to restore the water level and maintain normal circulation inside the drum. Finally, boiler pressure, water level and circulation return to normal. The boiler is cleaner and safer for continued operations. We will explain the surface blowdown process. Dissolved solids and impurities accumulate near the water surface due to continuous steam evaporation. The surface blowdown valve, located near the normal water level, is open. This allows a small amount of high TDS water to be discharged continuously or intermittently. Surface blowdown controls the total dissolved solids TDS in the boiler water and helps maintain proper alkalinity, which is important to prevent corrosion. It also reduces the risk of carryover from dirty water into the steam. Because surface blowdown is controlled and gradual, it causes minimal change to boiler pressure and water level compared to the bottom blowdown. It also helps reduce scale formation at the water surface. Fresh with water replaces the discharged water, maintaining correct water chemistry and stable boiler operation. Why blowdown is so important? First, it prevents scale formation. During steam generation, water keeps evaporating to produce steam, and the minerals dissolved in the water, such as calcium and magnesium, become more concentrated. When their concentration becomes too high, these minerals start to precipitate and settle on the heating surface and boiler tubes, forming hard layers called scale. This scale acts as an insulator, reducing heat transfer, causing localized overheating, and may eventually lead to tube deformation or rupture. Scale can also trap moisture and chemical underneath, promoting under-deposit corrosion. By performing blowdown, we remove this concentrated water and dissolved minerals before they harden, keeping the heating surface clean and the boiler safe. Second, blowdown prevents corrosion. Corrosion happens because boiler water may contain dissolved oxygen, acids, chlorides, and other aggressive chemicals. These substances attack the metal surface, especially in areas where protective films are weak or damaged. If left unchecked, this causes splitting, thinning of metal walls, leaks, and even catastrophic tube failure. Regular blowdown reduces the concentration of those corrosive agents, maintains proper water chemistry, and keeps the metal protected, ensuring safe operation and extending the boiler service life. In conclusion, boiler blowdown is a vital maintenance process in marine smoke tube boilers, ensuring both safety and efficiency. By removing sludge, sediment, and concentrated dissolved solids from the water, blowdown prevents scale formation and corrosion, maintains proper water chemistry, and safeguards heat transfer efficiency. Water blowdown effectively clears settled impurities, while surface blowdown controls dissolved solids near the water surface. Together, they protect the boiler from damage, extend its service life, and ensure reliable steam generation for safe operation. That's all from me. Thank you.